Good morning, children.
Good morning, ma'am.
Today we are going to study the various ways in which we can classify the elements. Does anyone have an idea how many elements are present?
More than 100, ma'am.
Alright, that is a safe guess. Actually, there are 118 elements present. Yes, Ajay?
How did scientists come to know about the properties of so many elements?
Yes, that is very interesting. Let us take an example. Suppose you go to a shopkeeper. Do you think in the shop all the things are kept together? Suppose all the things were kept in one shelf. Would the shopkeeper find the things? No. So he needs to classify all the things in the shop and keep them in different shelves, like the biscuits together and the tea together. Like this, he has to classify these objects into different groups. Similarly, we are now going to study how to classify all these elements so that they are easier to study and learn about. As time passed, the number of elements kept on being discovered and the total number of elements became many, and it was difficult for scientists to learn and remember the properties of elements. So the thought process started how to classify these elements. In the beginning, the classification was done broadly into metals and non-metals. But each group was so big that it could not be worked efficiently with such big groups. As we came to know more about the properties of the elements, the scientists started thinking of different ways to classify the elements. The first attempt was made in 1817 by Johann Wolfgang Dobrener. He was a German scientist. He tried to classify the elements based on the molecular masses and the similarities in their properties. He identified some groups having 3 elements each, and he called them triads. These 3 elements having similar properties were known as Dobrener's triads. He said that when these 3 elements are placed according to increasing molecular masses, then the element in the center will have a molecular mass which would be the average of the atomic masses of the other 2 elements. For example, let us take a triad which is lithium, sodium, potassium. Here sodium is the metal in the center. So, the molecular mass of sodium should be equal to the average of the molecular masses of lithium and potassium. So, the molecular mass of lithium is 6.9 U and that of potassium is 39 U. So, if we take out the average, then it would be 6.9 plus 39 divided by 2, which is equal to 22.95, and the atomic mass of sodium is 23. So, this is true for this particular triad of lithium, sodium and potassium. He could identify 3 such triads, that is lithium, sodium, potassium, calcium, strontium, barium, and the third triad as chlorine, bromine, iodine. Now, the problem was that he could only identify 3 such triads and he could not classify all the elements known at that time into the triads. But still, his classification made the other scientists to think about correlating molecular masses and chemical properties for classification of elements. The next classification of elements was done in 1866 by an English scientist, John Newland. He gave the law of octaves. He said that when elements are classified according to their increasing molecular masses, then every 8th element will have properties similar to the first element, and he called this law of octaves, correlating it to the octaves of music. Now we have seen, like in Indian music, we have 7 notes, that is sa, re, ga, ma, pa, dha, ni, and the 8th note sa is same as the first note. Similarly, in Western music, the 7 notes are do, re, mi, fa, sol, la, ti, and the 8th note do is similar to the first. So that is why he called it the law of octaves. Let us take another example with beryllium as the first element. Then the 8th element will become magnesium. Now according to the law of octaves, magnesium should have properties similar to beryllium, and it was found to be correct. From magnesium, the 8th element would become calcium, and again it was found that calcium has properties similar to that of magnesium. So the law of octaves, that the 8th element has similar properties to the first element, had been proved. But the drawback of this classification was that after calcium, he could not classify the elements in the similar manner. When Newland gave his classification, only 56 elements were known, and he presumed that no other new element would be later discovered. But when new elements were later discovered, it was seen that they did not follow the law of octaves. The other drawback of this classification was that Newland, in order to fit in all the elements, allotted 2 elements to a slot also. Like for example, cobalt and nickel were placed together, and they were placed in the column containing fluorine, chlorine and bromine. But the properties of cobalt and nickel are totally different than that of halogens. Iron, which has similar properties to cobalt and nickel, was placed far away. So these were the drawbacks of Newland's classification, but his classification worked well only with the lighter elements. The main credit for classification goes to Dmitry Ivanovich Mendeleev. He is considered as the main contributor to the formation of periodic table. He used the molecular masses and correlated it with the chemical properties of element to classify the elements. When he classified the elements, 63 elements were known, and he classified them not only on the molecular masses but also based on their physical and chemical properties. He mainly concentrated on the compounds made by the elements with hydrogen and oxygen. He selected hydrogen and oxygen because both are very reactive metals and they react with almost all elements. So the formula of hydrides and oxides were used as one of the basic properties for classification of elements. When he classified the elements, there were 63 elements present, and he made 63 cards. On each card, he wrote one element and its properties. Then he sorted out these cards to group together the elements having the similar properties. He placed these cards on the wall, and he found that all the elements could be adjusted in the periodic table, and they were placed according to the increasing molecular masses, and it was found that there is a periodic recurrence of elements having the same properties. So he gave the periodic law, which states that the properties of an element are the periodic function of the atomic masses. Mendeleev's periodic table was then published in a German journal in 1872. And if we see the periodic table, we will find that the formula of the hydride and the oxide of the elements is given on the top of the group. The letter R is used to represent any of the element present in the column. For example, the hydride of carbon, which is CH4, is represented as RH4, and the oxide of carbon, which is CO2, is represented as RO2. Mendeleev classified the elements on the basis of the increasing molecular masses, and it was found that the elements with similar chemical properties were placed in the same column. So, Mendeleev's periodic table had 7 horizontal rows and 8 columns. Achievements of Mendeleev's periodic table. There were certain instances when Mendeleev had to place an element with slightly higher atomic mass before an element with slightly lower atomic mass. For example, in case of cobalt with atomic mass 58.9 was placed before nickel, atomic mass 58.7. This was done so that elements having the same chemical properties were in the same column. Cobalt had similar properties to iridium and rhodium, whereas nickel had similar properties to platinum and palladium. Similarly, tellurium was placed before iodine. This was done because tellurium has properties which are similar to oxygen, sulfur and selenium, and properties of iodine are similar to fluorine, chlorine and bromine. The second achievement was that Mendeleev boldly left some blank spaces in his periodic table. He said that these elements would be discovered later, and he also gave names for them. He used the prefix eka of Sanskrit, which means one. He gave the prefix eka to the element which was preceding in the same group. This was later proved to be true because when gallium, scandium and germanium were discovered, they were found to have properties similar to eka boron, eka aluminium and eka silicon. So, this gave credibility to Mendeleev's periodic table. Noble gases like helium, neon, argon were not present when Mendeleev gave his classification. They were discovered much later because of their inert nature and because they are present in a very small percentage in the atmosphere. But the best part was that when noble gases were discovered, they could be placed in a different column without disturbing Mendeleev's periodic table. Limitations of Mendeleev's periodic table. Mendeleev could not give a position to hydrogen atom because the electronic configuration of hydrogen is similar to that of alkali metals, and so hydrogen forms compounds with oxygen, sulfur, halogens similar to the alkali metals. For example, hydrogen forms HCl similar to NaCl, it forms H2O similar to Na2O, and it forms H2S similar to Na2S. On the other hand, hydrogen also behaves like the halogens because it forms molecules like halogens. Hydrogen forms hydrogen molecule with the formula H2. Chlorine forms chlorine molecule with the formula Cl2. Also, hydrogen, like halogen, forms covalent bonds during formation of compounds. The second drawback of Mendeleev's periodic table was that it could not give correct position to isotopes. Isotopes are atoms having different molecular mass but same chemical properties because they belong to the same element. For example, carbon has isotopes C12, C13, C14, and chlorine has isotopes Cl35 and Cl37. Now, since these isotopes have different molecular masses, they should be placed separately, but they have identical chemical properties, so they should be placed together. So Mendeley's periodic table did not have places for isotopes which were discovered later. Atomic masses do not increase in a regular manner, so it was difficult to predict how many new elements will be formed between two consecutive elements. Especially this was the case with heavier elements. Anomalous position of some elements. For example, cobalt having slightly higher molecular mass was placed before nickel, and tellurium having slightly higher atomic mass than iodine was placed before iodine. Even with these drawbacks, Mendeleev's periodic table was a very important way of classification of elements. With that, we come to an end of this module based on classification of elements. Thank you, students.
Thank you, ma'am.
In this module, we have learnt about Dobrynev's triads. He made groups of 3 elements on the basis of atomic mass, in which the middle element had average atomic mass of the other 2 elements. Drawback: he could only find 3 triads. This could not be applied to all metals known at that time. Newland's law of octaves. Elements are arranged in increasing order of atomic masses. Properties of 8th element is similar to the first element. Drawbacks: applicable only up to calcium, adjusted unlike elements together, worked only for lighter elements. Mendeleev's periodic table examines relationship between atomic mass and physical and chemical properties. Arrangement of elements in increasing order of atomic masses led to periodic repetition of elements with similar properties. Periodic law: properties of elements are periodic function of their atomic masses. It contains 8 vertical columns and 7 horizontal rows. Achievements: study of elements became simpler because of placement of similar properties of elements in a group. Prediction of new elements. Placement of noble gases without disturbing the order. Limitations: position of hydrogen was not confirmed. Position of isotopes could not be assigned. Prediction of new elements was uncertain because of inconsistency in the atomic mass increase. Before moving on to the next video, you have to answer the following questions correctly.